Okay, I already have the problem written out here. That's because I started to do this proof, and before I had gotten started really, or gotten very far, I got a call on my telephone and had to stop the recording. So I'll just pick up where I was going to leave off, and I'll walk you through what we have here. This says it is not the case that there exists an X such that it is not the case that if Sx then Px. Honestly, when I see that, one of the first things I think about is change of quantifier. This looks very well set up for a change of quantifier here. I don't know we're going to use that, but it looks like it's, you might say, sort of begging for it at some point. Think about this. It says there isn't anything, that's what that says. It's not the case there exists an X, so there isn't anything such that this isn't true, right? There's not one thing where this isn't true. Change of quantifier will then tell us, well, if there's not one thing where this isn't true, this must be true for everything, right? For all x, if Sx, then Px. I expect we'll use that, but we'll see. Typically, when you learn a rule like change of quantifier, you're going to see it come up in proof problems. They want you to learn it, so they're going to give it to you. I'll give you a chance to use it. The next premise here says there exists an X such that Sx, and then suppose you get to the conclusion, there exists an X such that Px. Okay, so what I'm thinking here, I see the Px, right, that's what I need to get to, that's my conclusion. I see it right here, it's in the consequent of this conditional, right? When I see something I'm looking to prove in the consequent of a conditional, I start thinking I'm going to use modus ponens at some point, right? To use modus ponens, I need to be able to work with this information, right? And I see that this looks like, it looks pretty close, right? I mean, I have that quantifier there. It's kind of in my way right now, right? I can't use modus ponens directly here yet, right? Because this antecedent just says Sx. It doesn't say there exists an X. Exists an X Sx. So I'm probably going to need to basically kind of rewrite some things a little bit, maybe instantiate so I can start working. Another sort of general, or at least very common thing you see a lot with these proofs in predicate logic is you have to instantiate because you want to be able to use the rules from chapter 8. So you want to be able to instantiate to a constant or maybe a free variable, use your rules from chapter 8, and then to get to the conclusion, the quantified conclusion, you probably have to do a generalization, either existential or universal. In this case, it would be existential generalization at the end. So what I'm probably going to do is rewrite this so it looks the way I want it to, right? I'll probably use a change of quantifier, then instantiate it. I'll need to instantiate this at some point, and then use my modus ponens to get to some claim about involving this, and then I'll use the generalization to get back to the conclusion I need. Let's take a look at how that might play out. Not really a lot I can do with premise 1 just as it is, but if I rewrite it, that'll get me where I want to go. If I say for all x, if Sx then Px, and that's just from line 1 by change of quantifier, right? Then now I need to do some instantiation, and here's where you want to be very careful. Right, I can instantiate line 3. I will instantiate line 3 at some point, right? Basically, that means I'll just drop that quantifier off and put a constant in here, right? I'm going to use a constant here, not a free variable, so I'll put a constant in there because a constant will give me an existential generalization later on. You need free variables in order to be able to do a universal generalization because you need to know it's true of any particular x or y, whatever the free variable is, before you can universally generalize. But here, I'm going to use a constant. Constant can be any letter you like, A, B, C, whatever. I'll use A in this case. Do I want to instantiate this first or this first? Once I instantiate both, if I do it in the right order, I can then do a modus ponens. Right? I'll have SA, if SA then PA, so I can get PA, and then I can do my existential generalization. But which do I do first? It's important that you do the existential instantiation first, right? I'll show you why this makes sense. I got SA here. That's from line 2 by existential instantiation. Then I do the other one. If SA, then then PA. That is from line 3 by universal instantiation. Okay, and that sets up everything I need for my modus ponens and gives me PA. Right, my lines 4 and 5 modus ponens. Right, 4 and 5 modus ponens, and then I might as well just go ahead and finish the proof since I'm right at the end. I get, using an existential generalization, that's a terrible backwards E. There exists an X such that Px, I mean, I know P applies to A, so I know it applies to something. That's all this says. And that is from line 6 by existential generalization. Right, that's the whole proof. I'm going to go back and explain why it was important that we did the existential instantiation here before the universal instantiation. If it had gone the other way around, we'd have an error. So if I instantiated the universal statement first, if I instantiated this first, and I had that on line 4, if I had if SA then PA, and then I went to apply the existential instantiation, well, the problem I would have is when I instantiate the universal, I know it's true for everything, so it's going to be true for some constant, and I just name that constant A. But when I name that constant, I just picked out something. I don't know what A is, but it's something in the universe. It's, my desk or the Eiffel Tower or my left foot, whatever it may be. It's something. When I then instantiate the existential statement here, I only know that this is true of something out there in the universe, right? There exists an X such that SX. So if I've already named this thing and picked out something in the universe when I instantiate the universal, say it's the Eiffel Tower, right? I don't know that 2 is true of the Eiffel Tower. I don't know that the Eiffel Tower is the X. So when I name the thing that it refers to, I can't use A. I can't just assume that it's the same thing that I just instantiated when I instantiated line 3. So if I go in that order, it'll be counted incorrect because I will be making an assumption I'm not entitled to. I'll be making an assumption that the thing I picked out when I instantiated the universal is the same thing that's named in the existential statement, and you're not entitled to assume that. But if you go the other way around, it makes sense because here I pick out the existential thing first, say the Eiffel Tower. I know this is true of everything, so when I instantiate it, I can assume that it applies to the Eiffel Tower as well. Right? So if you go in that order, everything is good. All right, so anyway, there's the proof. I know that's a bit of a long video, but I wanted to explain some of those key steps. Hope that helped.